Welcome to this section on building and deploying your serverless stack. In the previous sections, we created a fully functional serverless data API using the API Gateway, Lambda, and DynamoDB, and shown you how it can be tested locally and once it was deployed. Here we are going to show you how to deploy the Lambda code, configuration, and create resources without having to use the AWS Management Console. In this section, we are going to take a look at an overview of serverless stack build and deploy options, creating an S3 bucket IAM policies and IAM roles for resources, building and deploying API Gateway, Lambda, and DynamoDB. Welcome to this video overview of serverless stack build and deploy options. In this video, we're going to take a look at the challenges of provisioning infrastructure as code, building and deploying using the Serverless Application Model, building and deploying using the alternative options. So the challenges of provisioning infrastructure are that it used to be a very manual process. For example, administrators would be clicking on user interface driven configuration or logging into the servers and editing configuration files. This became more and more challenging with the growth of cloud computing and web frameworks that started to scale out. There's a lot of effort in doing this manually in terms of cost and also in terms of the ability to maintain such configurations at scale. This became slower to scale up and also to recover from any errors, as you would have the administrator, for example, going onto the box, rebooting the machine, or actually trying to understand what the issues were and actually changing the configuration many times for many machines. It's also very difficult to test and make repeatable. So any configuration changes, either using a user interface or in terms of configuration files on one server, were not very repeatable and also prone to human error and misconfiguration. So for example, earlier in the course we were using the AWS Management Console. So had you made some errors, for example, in any of the configuration, then you would have to go back and edit that, which is very time consuming. So this is why one of the motivations for infrastructure as a code and why this appeared. Infrastructure code is basically the process of managing and provisioning your resources through definition files or code. It provides a very centralized way to actually control that configuration in terms of implementation and version control. So suddenly the resource managing and provisioning becomes much more like the agile process in the systems development lifecycle in software. So managing any changes is done using validation and also a test release process. And there can be very standard deployment pipelines, for example, that are followed for the deployment of any new resources. This also provides the ability to almost copy configuration from one region. Let's say you would have a region in Ireland. For example, you could migrate the same infrastructure code configuration into other regions, for example, in North Virginia. So it allows you to scale out very quickly in terms of your configuration around the infrastructure. And this led to the development of the term DevOps. This is where the developers are getting much more involved in the configuration, especially around the infrastructure, and also the ops team or operations teams get much more involved in the development process. So there are many benefits in having infrastructure as a code. The first one you can see is cost reduction. So with a lot less effort spent on simple tasks, I'd say, and repetitive tasks, you also can reduce the cost significantly for deploying more infrastructure. The other point is the speed of execution. So suddenly your administrators or DevOps team can actually release infrastructure a lot faster than they would have done before. In addition, there's a reduction in risk of errors that can be introduced, for example, through manual configuration or user interface changes. And finally, through having traceability and validation and testing, and this risk around security is also reduced. Since you have this traceability, you can understand what was deployed, and then you can try and find out Is that an issue, or is it something we should revert, for example? So another tool that's emerged recently is the Serverless Application Model, which is an AWS tool that allows you to build and deploy your serverless stack. It provides a simplified way to actually define and deploy any serverless resources or applications. At the base, it uses CloudFormation, but using much fewer lines of source code. The basic concept is using a SAM template. So SAM is a file that can be JSON or YAML configuration. And the mascot is Sam the squirrel. You can see it on the right, which has been released at the last reInvent. Underneath, I've provided the link to the serverless application model with additional documentation if you need it. So there are alternative options to deploying your serverless stack. The first one is the AWS command line. We used the AWS command line earlier in the course, and it is an option when, for example, your organization does not want to use CloudFormation stacks for everything or parts of your serverless stack. The AWS CLI is also usually ahead of SAM in terms of feature releases. Serverless, initially called JAWS, it's built around Node.js technology. It was ahead of its curve when it was first released, but now with the AWS SAM, it's an additional layer on top of AWS that's maintained by a third party. However, it does allow you to use other functions from other cloud providers like Google and Azure, which is a great feature. Chalice and Zapper are Python-based frameworks for AWS and are similar to Python, Flask and Bottle micro-web frameworks. But again, they are another abstraction on top of AWS, so you need to wait for any improvements to cascade through. In addition, there's also a risk of having a dependency on those frameworks. When AWS features are deprecated, for example, you will need to keep in sync with them or rely on those other framework committers to actually make changes.